a step-by-step walkthrough of the Edexcel Foundation GCSE Maths Paper 2 from November 2018. Hey there guys, welcome back to the channel. If this is your first time here and you're trying to get the best grade in maths you possibly can, let me help. Start now by subscribing. Okay, before we get going, some useful things down below in the description so you can download the paper yourself down there. Every foundation past paper walkthrough is in a playlist down there. My brand new formula booklet video is down there. In this video, I tell you how you can get a PDF copy of this, and also I'll put playlists and videos to help with topics on this paper. Okay, let's do this. Number 1, write down the value of the 4 in the number 542.3. So, in saying the number, I've said the value. It's 40. Number 2, write down a square number that is also an odd number. Okay, 1. Or we could have 9 or 25, for example. 3a, we want to change 4,560 grams into kilograms. So 1 kilogram is 1,000 grams. So we divide this by 1,000, we get 4.56 kilograms. Okay, then for part B, we want to change 7.3 meters into millimeters. Okay, so let's do this in 2 steps. Let's go to centimeters and then millimeters. So every meter is 100 centimeters. So 7.3 meters is 730 centimeters. Now every centimeter is 10 millimeters, so multiply that by 10 and we get 7,300 millimeters. Okay, number 4, we want to work out the cube root of 64. So your calculator can do this. On mine, I need to press Shift and I think the square root button, and you get a square root with a little 3 sat on it. That means the cube root. Whack in 64 plus equals and you should get 4. And number 5, again your calculator can probably do this. So we want to write 0.31 as a fraction. So on my calculator, I can just put that in, press equals, and it gives me 31 over 100. Okay, number 6, here are 4 fractions, so we have 3 quarters, 5 sevenths, 19 25ths, and 11 15ths. We want to write the fractions in order of size, starting with the smallest. So, because they all have different numbers on the bottom, what we're really going to need to do here is turn each one into a decimal. So, 3 quarters is 0.75. 5/7 is 0.71, 2 decimals. 19/25 is 0.76. And then 11/15 is 0.7333 recurring. So we can just call that 0.73. Okay. So the smallest then is 5/7. And then it's going to be 11/15. And it's going to be 3/4. And then finally 19/25. Cool. Okay, number 7. So for number 7, we want to simplify 3m minus m minus m add 3m. Okay, so working from the left, 3m minus m is 2m. Minus m is 1m, add 3m gives us 4m. Part B, simplify 2 times n times p times 4. Okay, so multiplication is magic. Doesn't matter what order we do this in, so we could just as easily write this as 2 times 4 times n times p. So 2 times 4 is 8, so we have 8 times n times p. We can write that then as 8np. Okay, then number 8. We are told a map has a scale of 1 centimetre to 14 kilometres. On the map, the distance between Manchester and London is 18.8 centimetres. What is the real distance in kilometres between Manchester and London? Okay, so every 1 centimetre represents 14 kilometres. So we need to do 18.8 times 14 kilometres. Remember again, it's a calculator paper, so 18.8 times 14 gives us 263.2. kilometres. Okay, number 9a. The nth term of a sequence is 3n add 4. We want to explain why 21 is not a term of this sequence. So, if 21 was a term, there would be a whole number value for n such that 3n add 4 is equal to 21. For example, the third term would be 3 times 3 add 4. So that would give us 13. So 13 is a term. So let's see what happens if we try and solve 3n add 4 is equal to 21. Well, that's going to give us 3n is equal to 17. And then if we divide by 3, n is 17 over 3, which is not a whole number. So, we could say there is no whole number value for n that makes this work. Therefore, 21 is not a term in the sequence. Given for part B, we are given the first 3 terms of a different sequence, 1, 2 and 4. We want to write down 2 numbers that could be the 4th and the 5th term of the sequence. We want to give the rule you have used to get your numbers. So there are at least 2 rules we could use. First of all, we could multiply by 2 each time. So 1 times 2 is 2. 2 times 2 is 4. So our 4th term could be 8. And then 8 times 2 would be 16. So if we went with that, the rule that we've used is to multiply each term by 2. The other one that we could use is that, first of all, to get from 1 to 2, we have added 1. To get from 2 to 4, we've added 2. So we could then add 3 to get 7. And then add 4 to get 11. So that's another possibility. The one I would go with is multiplying by 2. Simpler. Okay, number 10. Here is a number machine. So we have our input. We times it by 5. Then subtract 2. And then we get our output. Part A wants us to work out the output when the input is 8. Okay, so 8 times 5 is 40, and then 40 minus 2 is 38. Okay, then part B wants us to work out the input when the output is 28. So, for this, we work from the right back to the left. So, we first of all do 28 add 2, because we also do the opposite of what the number machine did from left to right. So 28 add 2 is 30, and then 30 divided by 5 is 6. Okay, number 11. Adam gets a bonus of 30% of £80. Katie gets a bonus of £28. We want to work out the difference between the bonus Adam gets and the bonus Katie gets. Okay, so we need to work out 30% of £80. pounds. So, now you could of course find 10%, multiply that by 3, but this is a calculated paper, so the quick way to do this is to do 0.3 times 80. And that is going to give us £24. So the difference is 28 minus 24, which is £4. Okay, number 12, I can count. There are 49 counters in a bag. 20 of the counters are red. The rest of the counters are blue. One of the counters is taken at random. Find the probability that the counter is blue. Okay, so for that we need to know how many counters are blue. So there are 49 counters. 20 are red, the rest are blue, so take 20 away. That gives us 29. So there are 29 blue. Now the probability then that a counter is blue is 29 out of 49. Okay, number 13. A square has an area of 81 centimeters squared. Part A. Find the perimeter of the square. Okay, so what makes a square a square? Every side is the same. So if we call a side x, then to get the area we do base times height. So that tells us then that x squared is equal to 81 centimeters squared. Now if we square root, we get x is equal to 9 centimeters. Now the perimeter means the distance around the outside, so that's all 4 sides. We now know a side is 9 centimeters, so the perimeter is 4 times 9 centimeters, which is 36 centimeters. Okay, then for part B. Okay, so down here then the diagram shows a rectangled triangle and a parallelogram. We are told the area of the parallelogram is 5 times the area of the triangle. The perpendicular height of the parallelogram is h centimeters. We want to find the value of h. Okay, so to do that, we're going to need to know the area of the parallelogram. Now, this one, parallelograms always cause problems. It's in my formula booklet. The area of a parallelogram is the same as a rectangle. It's just base times height. So, what we're going to need to do is work out the area of the triangle. So, also in my formula booklet, the area of a triangle is base times height divided by 2. So, we need to do 16 times 9 divided by 2, and that is going to give us 72 centimetres squared. Okay, now the question tells us the area of the parallelogram is 5 times the area of the triangle. So the area of the parallelogram is 5 times 72 centimetres squared. Which is 360 centimetres squared. Okay, now we need to get the dimensions of the parallelogram involved. So as I said, it's the same as a rectangle, so it's base times height. So that means then 30 times h . 30 times h then is 360. So we then divide by 30 and we get h is equal to 12. Okay, number 14. Veronica throws an ordinary fair 6-sided dice once. She says the probability of getting a 3 is half the probability of getting a 6. Is Veronica correct? You must explain your answer. Okay, so no, she is not correct. So the explanation would be, on the dice there is only 1 3, there is only 1 6. So the probability of getting either 1 is 1 out of 6. So the probabilities are the same. Part B. Andy throws the dice twice. He says the probability of getting a 6 on both throws is 2 out of 6. Is Andy correct? You must explain your answer. So again, Andy is not correct. When you do an event, say twice here, you don't add the probabilities, you multiply them together. So the probability would actually be 1/6 times 1/6, which would be 1 out of 36. Okay, then for part C, we are told that Indri, maybe, throws the dice once. She also flips a coin to get heads or tails. We want to list all of her possible outcomes. Okay, so we could get a heads and 1, heads and 2, heads and 3, heads and 4, heads and 5, heads and 6, tails and 1. You get the idea. Okay, number 15. Remy invests £600 for 5 years in a savings account. At the end of the 5 years, he has received a total of £75 simple interest. So, simple interest is when you get paid the same amount each year. So, our job is to work out the annual rate of simple interest. Okay, so over 5 years, he's made £75 each year. He's made the same amount. So, £75 divided by 5 is 15. So, he has made, as a percentage, £15 out of £600 multiplied by 100. So the percentage rate is 15 out of 600 times 100. So that is going to give us 2.5%. Cool. Okay, then for number 16, we want to describe fully the single transformation which maps shape A onto shape B. So, hopefully you can see the shapes are symmetrical through the x-axis, so it's a reflection through the x-axis. In number 17, Adrian is going to make concrete. He is going to use 108 kilograms of cement, 375 kilograms of sand, 1008 kilograms of stone. Cement, sand and stone are sold in bags. One bag of cement is 25 kilograms, a bag of sand is 22.5 kilograms, and one bag of stone is 50 kilograms. Adrian already has 10 bags of cement, 20 bags of sand, 20 bags of stone. We want to work out what bags he needs to buy to make the concrete. Okay, so he has then 10 bags of cement. So 10 bags of cement is going to be 250 kilograms. So he needs 180 kilograms, so he has enough. He has 20 bags of sand, so 20 times 22.5 is 450 kilograms. Now, for the sand, he needed 375 kilograms, so he has enough sand. Now, with the stones, he has 20 bags of stone. 20 times 50 kilograms is 1,000 kilograms. Now, he needs 1,080 kilograms, so he needs 80 kilograms more stone. So, for that then, he's going to need 2 bags of stone. Okay, number 18, Bill wants to increase 150 by 3%. He writes down 150 times 3 is equal to 195. Bill's method is wrong. True story. Part A. Explain why. So, by multiplying by 1.3, he's increased it by 30%. So, he should have multiplied by 1.03. Because 3% as a decimal is 0.03. Okay, then for part B, Sally wants to decrease 150 by 3%. Complete this statement to show how Sally can decrease 150 by 3%. So, if you want to decrease something by 3%, you want 97% of that something. 97% as a decimal is 0.97. So, we are going to do 150 times 0.97 and we get 145.5. Okay, 19a, we want to solve 3 lots of x minus 4 is equal to 12. So, two choices, we could expand the brackets and then solve, or we can just get rid of the 3 now. So the 3 is multiplying the brackets. To cancel that out then, we divide both sides by 3, so we get x minus 4 is equal to 4. And then we need to add 4 to both sides, so we get x is equal to 8. And for part B, we want to factorise fully 9b minus 3b squared. So when they say factorise fully, they're giving you a clue that there is more than one type of common factor. So here we have a common factor of 3 and a common factor of b. So if we take out the b, first of all, we get b times 9 minus 3b. So now inside the brackets there is still a common factor of 3. So we're going to stick a 3 on the outside. So we now have 3b. And inside the brackets we divide by 3. So we have 3 minus b. Okay, number 20, Venn diagrams, and the first question also on the higher paper. So, the little squiggle is epsilon. It means a universal set. In English, that just means everything we are interested in. So, everything we're interested in here are the even numbers between 1 and 25. So, subset A is 2, 8, 10, 14, B is 6, 8, 20, C is 8, 18, 20, 22. Part A wants us to complete the Venn diagram for this information. So all of the even numbers between or from 2 to 24 have to go somewhere in this Venn diagram. So 2 is only in subset A. So 2 is just going to go there. Next one would be 4, so it's in none of the subsets, so it goes on the outside. But inside the rectangle. Next one would be 6. 6 is in B. 8 is in all 3 subsets, so that's going to go in the middle. 10 is in A and only A. 12 is in none of the sets, so that goes on the outside. 14 is in A only. 16 is in none of the subsets, so in the rectangle. 18 is in C only. 20 is in B and C, so that's going to go there. 22 is only in C, and 24 is in none of the subsets, so it goes in the rectangle. So that is the Venn diagram. Part B then tells us a number is chosen at random from the universal set. Find the probability that the number is a member of A intersection B. So what that means is the overlap of set A and set B. So we're interested in every number inside that part. So in there is only one number. The set on the whole has 12 numbers, so it's 1 out of 12. Number 21. Sean has info about the height in centimetres and weight in kilograms of each of 10 rugby players. He is asked to draw a sketch graph and align a best fit for the info. Here is his answer. We're told Sean has plotted the points correctly. We want to write down 2 things that are wrong with his answer. Okay, so the most obvious is that his line of best fit is a load of rubbish. It should be something more like that. So that's one thing wrong. His line of best fit is not good. And the other is down here on the bottom, where we have the scales. So first of all, one big square takes us from 140 to 160. And then the next big square takes us from 160 to 170. So we can say the scale for the height is not consistent. Okay, number 22. BEG is a triangle. We are told ABC and DEF are parallel lines. Work out the size of angle X, which is off on the right. And we want to give a reason for each stage of your working. Okay, so angle X is inside a triangle, angles in triangles add up to 180. So if we can find the other two, bingo. So first of all, down here, we have this angle of 110, a blue angle, and an angle of 25. Now, because they lie on a straight line, they have to add up to 180. So that would be your reason for this step. So 110 add 25 is 135. 180 minus 135 is 45. So this blue angle is 45 degrees. Okay, so can we do anything up here? Well, we can actually work out this angle here. So this green angle and the 110 degree angle are co-interior. So co-interior angles add up to 180 degrees, so the green angle is 70 degrees. Again, you would want to write down the reasoning. Okay, so now again, we have three angles on a straight line. So 70 add 35 is 105. 180 take 105 is 75 degrees. So now we know two angles inside this triangle. So the final reason you would want to write down is angles in a triangle add up to 180, and then 75 add 45 is equal to 120. 180 minus 120 is 60. X is 60 degrees. Okay, number 23, we have compound interest, so my percentage increase and decrease playlist is down below. Okay, so Northern Bank has two types of account. Both accounts pay compound interest. So with a cash savings account, interest is 2.5% per annum. Annum means year. And with a shares account, you get 3.5% per annum. Ali invests £2,000 in the cash savings account. Ben invests £1,600 in the shares account. Part A wants us to work out who will get the most interest by the end of 3 years. You must show all of your working, of course. Okay, so let's do Ali first. Okay, so Ali is getting 2.5% interest. So 2.5% is 0.025. So the decimal multiplier we're going to use is 1.025. So Ali is going to have £2,000 times 1.025. Now that would work out how much she has at the end of 1 year. We want 3 years, so we just stick a power of 3 on the multiplier. Now that gives us £2,153 and 78p. So our interest is £153, 78p. Okay, now for Ben, .5% is 0.035. So for Ben, we do 1,600 times 1.035 to the power of 3, and that gives us £1,773 and 95p. So his interest is then £173 and 95p. So Ben gets the most interest. Okay, and for part B, we are told that in the third year, the rate of interest for the shares account is changed to 4% per annum, so it's increased. Part B, does this affect who will get the most interest by the end of 3 years? Give a reason for your answer. So Ben has the shares account. Ben already got the most interest by increasing his interest rate. He's just going to get more interest. So the answer is no, Ben will still get the most. Number 24, the diagram shows a floor in the shape of a trapezium. John is going to paint the floor. Each 5 litre tin of paint costs £16.99. 1 litre of paint covers an area of 2 metres squared. John has £160 to spend on paint. Has John got enough money to buy all the paint he needs? You must show how you get your answer. Okay, so we're going to need to work out the area of the floor. We're going to need to work out the area 1 tin can cover. We then divide the area of the floor by the area 1 tin covers to work out how many tins we need, and then we'll go from there. So, let's do each tin first of all. So, each tin is 5 litres. 1 litre covers 2 metres squared. So, 1 tin covers 10 metres squared. Okay, now then, the floor then is a trapezium. You need the formula for the area of a trapezium. So here it is in my formula book. So we add the top and bottom together, multiply it by the height and divide by 2. So the area of the floor So it's going to be 7 times 10 add 16. All divided by 2. Now check that you can get that being 91 meters squared. So now we can work out the number of tins needed. By dividing the area of the floor by the area each tin covers. So 91 divided by 10 gives us 9.1 tins. So obviously you can't buy 0.1 of a tin. So John must buy 10 tins. So the cost of that is going to be 10 times 16.99. So that's £169.90p. John only has £160, so no, John can't buy all the paint he needs. Well, John. Key number 25, A is the point with coordinates 5, 9, B is the point D, 15. The gradient of the line AB is 3. Work out the value of D. Okay, so my strict line geometry playlist is down below, where we cover gradient, things like that, separately and together. So gradient is usually called M, and it's the difference in Y divided by the difference in X. So here we can do 15 take 9. Now because we've done 15 take 9 on the bottom, we have to do D take 5. So this one is 6 over D take 5. Now we know the gradient is 3, so that means that we know 6 divided by D minus 5 has to equal 3. Now 6 divided by 2 is 3, so that means D minus 5 has to be 2, so D is 7. Key number 26A wants us to expand and simplify 5x add 2 times 2x minus 3. So that is quite a nasty one to see on Foundation. I highly recommend using a table. So it needs to be a table like that. So we're going to put 5x and 2 along the top, and then 2x minus 3 down the side. Now each part of the table now is a multiplication between the thing at the top and the thing at the side. So 5x times 2x is 10x squared. 5 times minus 3, 5x times minus 3 is minus 15x. 2x times 2 is 4x. And then minus 3 times 2 is minus 6. Okay, so that's the expanding done. Now we need to simplify. So we have 10x squared now we have minus 15x add 4x, so that's minus 11x, and then minus 6. Okay, then part B says to factorise x squared add 4x add 3. So that means to put back into brackets. So with a quadratic like this, and I'll put my quadratic playlist down below with all these skills, we want to have 2 pairs of brackets. Each one has an x in them. Now the two numbers multiply together to give us 3 and add together to give us 4. So it's going to be x add 1 times x add 3. Okay, number 27a, we want to write the number 0.0007547 in standard form. So we're going to need 7.547. That's going to be times 10. Now, because the number is less than 1, it's a negative power. And to work out the power, we need to know how many places the decimal moves from there to where it is on the left. So it's gone 1, 2, 3, 4, 5. So the power is minus 5. Part B says to write 3.42 times 10 to the power 4 as an ordinary number. So with a positive power of 4 on the 10, the decimal point moves 4 places to the right. So we're going to get 3, 4, 2, and then we need 2 zeros. So it's 34,200. Okay, then the final question, we want to work out 2.3 times 10 to the 4 times 6.7 times 10 to the 3, all divided by 5 times 10 to the minus 8. So, put that in your calculator, exactly how it looks here, and we will get 3.082 times 10 to the power 15. Okay then guys, there's that paper complete. If you found this useful, don't forget to give us a thumbs up, get subscribed, drop us a comment with any requests, share with your friends because they may need help too. Take it easy, take care.